The first characteristic that it wants you to identify or describe is the difference between a female and a male fruit fly. And so if we look here on our lab, then what we see is we have, this is what a female looks like, okay? And this is what the male fruit fly looks like. So we can note some differences on these two sexes of flies. And so if you look, we're kind of describing basically the abdomen is differently shaped, right? The female has a more pointed abdomen with a um, smaller black band on the bottom. And then the other identifying characteristic is up at the top on the legs. You have these little brushes, these little black brushes that are called sex combs, and they're for attachment during mating. And so the males are going to have those. And so you're going to describe that kind of briefly in this handout portion where it says describe and draw a little sketch of what makes them distinctly different from each other. Don't get too detailed with the sketches. And so that's the first part. The next part is looking at the wing size because those are the traits that we're going to start with analyzing. And so we're talking about the wing size here. We have different types. Our wild type is our dominant normal type wing, and we can see that it's kind of longer. I said it's probably about almost twice as long as the size of the abdomen. And so we can see those wings kind of look like normal fly wings. Then we have vestigial, and vestigial wings, if you look at them, they do not look like normal healthy wings, right? They look kind of crimped, and obviously these are going to be flightless variety. And then the last one we have are apterous, and apterous wings are just, there are no wings, right? And so you're going to kind of explain that and describe or sketch that here, okay? And so what this lab does is it's looking at these traits for that are common in fruit flies that are distinct. So we're going to talk about a little bit about how we're going to notate the alleles for these. Anything that is a wild type, we're going to denote with a plus sign for that allele, but we're going to base it upon whatever recessive trait is that it is being crossed with. And so what do I mean by that? So for example, if I'm talking about vestigial wings, like this first cross, then for a wild type, I would say, okay, the wild type would be VG plus, VG plus. And so it's homozygous dominant, if you will, or what we're assuming is homozygous dominant. And it's the wild type for a cross with a vestigial parent. And so the vestigial parent would be VG, VG without the plus sign. The plus denotes the wild type, which denotes the dominant allele. I know there's a lot of letters and pluses, but that's why I'm giving you this information up front. And so for the apterous, if I was doing um, crossing the wild type with the apterous wing, then I would do something like this. The website just uses a plus sign to denote wild type, okay? And so we're going to do it a little bit differently because it's easier to keep up with what trait we're actually talking about, right? And so if they have apterous wings, those are recessive, we're going to put the AP, right, for a fruit fly that is homozygous recessive for these apterous non-existent wings. Okay, so I'm going to walk you through this first cross all the way through from beginning to end so you know what you have to do with the other two crosses. We're going to do dihybrid crosses as well, but we're starting with the simple ones. So the first thing that they want us to do is we're going to be crossing a wild type female with a vestigial male. And so I'm writing that VG plus, VG plus. Why? Because it's a wild type, but we're crossing it with a vestigial. And so the dominant allele for that would be VG plus. And then we have a vestigial male, so that means he's homozygous recessive, which means he doesn't get the plus signs. Okay, so what you're going to have to do at this point is get a separate sheet of paper to show a lot of your work. Okay, and so that's what I'm going to do is I'm going to go to my blank piece of paper. And so we're taking those two parents and we're doing a Punnett square to cross those parents together. So I have a Punnett square here, and I'm going to put VG plus, that's the female parent, and I'm going to put VG, VG, right? This is going to be important in a little bit. And so we're going to go ahead and do this. All of my F1 offspring, so this is my P parental of cross number 1. That's where I'm at, okay? That's my P. So all of them are going to be heterozygous. How do I know? Because all of them are getting that dominant allele and one recessive allele. Right, so these are our expected results of our parental cross. If you look at the paper, we're also going to do an F1. So I'm going to go ahead and do that Punnett square right here, and you can do it with me. So F1, remember, is we take two of the offspring from the parental generation and we cross them together. And so we take the ones that are heterozygous, VG plus and a VG, and we do a Punnett square with them to figure out what our outcome is. And we're looking for our phenotypic outcome. And so that means what they look like. How many of them are wild type and how many of them are recessive. And so if we look at this, if we're just looking at them, then these three are going to have that dominant wild type phenotype, right? And so my expectation is that my wild type will be 75% of my offspring, 3 out of 4, and my vestigial will be 25% of my offspring. So this is my F2 offspring that I expect. Okay, so this is my expected F2 offspring. All right, and so that's going to become important in a minute. What we're going to do now is we're going to go back to that page. We are going to fill out on the front, it asks for your parental genotype, so we're going to fill that out with these parents, and we'll go ahead and do that real quick before we move on to the next part. So we are here, okay? Down here at the bottom, it says, what are the genotypes of your P generation for each cross? So that's these guys we wrote up at the top right here. So we're going to write those down in this blank. Okay, so we're going to do that first. And now we can finally get to the website and start doing the actual crosses. So what we're trying to find now, we're trying to do these crosses and see what our results are and how many offspring we get of each type. And so we're going to start here. We started with, it said a female that was normal. So we need one that has a wild type female, which is what we have. So we hit select. Then we hit design fly to find our male, and our male is supposed to be vestigial. And so we find wing size, vestigial, and we select that fly and we make them. Now right now it doesn't matter male versus female, and so we can actually kind of skip this part and go to analyze and ignore the sex of flies. And that gives us our total. All of them are plus, and plus means wild type. So let's look at our paper. So all of them are plus, which means they're all wild type. I forgot what the number was, so I'm going back. My apologies. 1034. Okay, and I'm going to write that 1034 here. If you did it on your own, you're going to get a different number. If you want to keep my number for this first cross, then that's fine. But you should not have identical numbers to your partner because you're running this yourself. You should have different numbers, so your values will be slightly different and your results will be slightly different. And so just keep that in mind. We didn't have any other types, so we have 0 for this. And you can look at the proportion here, or you can do a percentage. So if we're doing a percentage, that would be 100 to 0. 100% wild type, to 0 vestigial because those are the ones that we're looking at right here. Okay, now here comes the next step. Our next step is to mate the children of these parents. So we're mating the F1 offspring together, and we're going to get these. These are the observed values. Remember, for chi-square, we have an observed and we have an expected. And so that's what we're going to figure out before we move on. So let's go back. I guess this is where I am. Great. Let's go back to our crosses. So these are our parents and these are the offspring. These are the ones that we want to look at. Okay, these are my offspring. We hit select and select. So we picked those offspring and we're going to mate them. And we're going to get our results. Our results are the bottom offspring of cross 2. Again, we go to analyze and we hit ignore sex of flies because it's not important. Okay, so these are our results. Let me see if I can do this. Okay, there we go. These are our results. So I'm on my paper. I'm writing down the 736 and the 252. Okay, and 0. If we want to do the proportion, we can just put, if I'm rounding, I have 74 to 26. I took these proportions and I just turned them into a percent, right? Because I have 100 and 0 over here, so I have 74 to 26 over there. All right, so now we are going to start doing some math. So let's go back to our work that we had worked out. Okay, these are our numbers, but we have to do a little bit more on this side to determine how many flies we would actually see if our results match what we expected. And so we have a total of 988 flies for this cross. And so what I'm going to do is I'm going to take that wild type here, and I'm going to figure out what I expect for that. So I have 988, and I'm going to multiply that by 0.75. So I took that percent, I turned it into a decimal, and I'm going to multiply that to get a value. And that's going to be my expected number of wild type fruit flies. Okay, so 988 times 0.75, 741. So that's my first expected value. These are my expected values for my chi-square. And then I'm going to take the other one, the other number, the 25%, do the same thing, right? With that 988, except I'm multiplying it times the 0.25. Ninety-eight times 0.25 is 247. Whoa, sorry, 247. And so those are my expected values, and I'm going to use those to calculate chi-square. Okay, I'm going to use those with my observed values from this lab that we did over here on the left. All right, so this is cross number 1. Now we're going to do chi-square, so we're going to zoom in over here, and we're going to calculate our chi-square for this cross, right? And so we have, again, our observed minus our expected. So how do we do chi-square? We take the sum of the observed minus the expected squared over the expected. And we take all of them separately and we add them up. So we only have 2 that we have to do. So it's not that bad, right? So our first one is 736 minus that first expected value, so 741, divided by squared, divided by that expected value. I'm just taking this formula and I'm plugging in my numbers. Then I add my other one. So I have my observed, which is, okay, so my observed is 252 minus my expected squared over 2 over my expected. And so I'm going to fill this out, right? I kind of do it step by step because I'm afraid I'm going to mess it up. So I get 0.033, 0.101, and I add those together. Yes, you're going to have a little bit of a difference if you know how to put it into the calculator correctly. But I'm going to pull it out to 3 decimal places, and I'm going to have a point 134 as my chi-square. So all of this work was for cross 1. You understand that this is invested, okay? So you're going to have to do some work. Let's go to the lab. Okay, this information is not on the front. I'm showing you the entire process a little bit. So we're going to skip to this page right here. Okay, it did ask me what were the genotypes of my F1 generation, and so that's where we did that Punnett square. So we had the heterozygous parents for that first cross, so we can go ahead and fill that out. Remember our null hypothesis here, we're trying to determine. Remember, the null hypothesis is that there's no significant difference between our observed and expected values. So if we apply that in this case, then our null hypothesis is there's no significant difference between the observed and expected offspring. Okay, that's our null hypothesis, that our offspring traits. And that's pretty much going to be our null hypothesis for every one of these crosses, that there's no significant difference between what's observed and what's expected in our offspring. So we're going to look at our, we're on page, we're still on this page, I'm sorry. We're going to look at our chi-square, which I calculated at 0.134. Okay, that is going to be right here. So our chi-square is 0.134. Remember that our degrees of freedom is our number of options minus 1. And so we only have 2 options. We have wild type and the recessive. And so our degrees of freedom is 1 because it's 2 choices minus 1. So what is our critical value? Remember, we always look at 0.05, right? And so our critical value is 3.84. Sorry. And so do we reject or we accept? So we reject the null hypothesis if our value is greater than 3.84, and we accept if it's less. So in this case, we would choose to accept. And that's how we do this lab. Yes, it's long, but show your work. Okay? We'll work on it together, and you ask for help if you need it.